Hello everyone. In today's video, we'll be discussing about the use of matplotlib in C++ for data plotting and visualization purposes. Today, we'll see minimal working examples with matplotlib-cpp, while our focus will also be on how to set up matplotlib in C++. Those who are new to matplotlib, matplotlib is a powerful Python library for plotting and data visualization, and in today's video we'll be exploring its functionalities in C++ side. So there is a header file called matplotlib-cpp that we need to download and put it in our working directory, and then we'll be able to use all the matplotlib functionalities in C++ side as we would have done in Python. It is worth spending time in this video because matplotlib is useful for many computational purposes when we are interested in visualizing the trend of the data, or we need to plot some graphs out of some computation that we are doing using simple calculations or using eigen library calculations, all those stuff. So using matplotlib in C++ is definitely helpful. Further, I'll show you how to set up C++ environment to work with matplotlib-cpp. So that's also something will be useful, as you will see later. Please note that in today's video, I'll be using Python package manager Anaconda for all Python related files and packages. Now, the first thing that we need to write codes using matplotlib-cpp is to download the matplotlib-cpp.h file, which is the header file which has all the required functionalities and Python wrappers. So basically, we first open our browser and we need to get to the matplotlib-cpp's official website, and then you click here in this link and it will take you to this GitHub profile, and in that GitHub repository you scroll down a little bit and you find this matplotlib-cpp.h file. You click on that and then you have the required header file with you. So all you have to do now is you need to copy this entire file and create a file named matplotlib-cpp.h and put it into the current working directory. I am not going to copy this because I already have done this, and you can see that this file is sitting right in front of right inside the current working directory. In my case, the working directory name is matplotlib, and as you can see that matplotlib.cpp.h is already there. Okay, so we are good for the first step, and that completes the first step in obtaining the header file. The second step is setting up a few Linux environment variable. In our case, we need to set up two environment variables. The first one is ld library path and the second one is Python home path. So in order to check whether in our ld library path the required path is already set or not, we first need to echo the ld library path. So we type echo $ld underscore library underscore path, and we see that in that particular variable the Anaconda Python version is already set up. So I am basically using a virtual environment in Anaconda. The name of the virtual environment is robotics, and I am inside the Anaconda 3 package manager. So we are good here. The next thing that we need to set is the Python home path. So we again check what is there in my Python home environment variable. So what we do is we say Python home and we see that in Python home we have nothing set yet. So we need to set the Python home. So in order to set the variable, we need to say that export then dollar then Python home, and then we set the export Python home is equal to dollar Python home, and then we append whatever path that we want to set. In our case, we'll be using Python that is available through the Anaconda inside the robotics virtual environment, which in our case is robotics Python environment. So we first start inverted comma, then we say /home/ this is my username, then Anaconda 3, then environment folder, that is envs/robotics, and you end the inverted comma. Now that we have set our Python home, let's check whether the variable has been set or not. As we see that it's still having some issue with Python home. Let's say what's going wrong here. Okay, so there was a typo. Now I have fixed it. And hopefully we'll see the required path. As we see that we have the two same path now appended together, but however it doesn't matter, the same folder name could be twice, that's not a problem. Okay, so now that we have our required header file ready and we also have set the environment variable, we are now good to write our first code using matplotlib-cpp. So we start with including the matplotlib-cpp.h file. So we start with hash include, then start and close inverted comma and type matplotlib-cpp.h, and then we'll also be using std vector, so we'll include vector, and we'll also probably need the cmath, so we'll include that too. And then we mentioned that we'll be using namespace plt is equal to matplotlib-cpp. Okay, so this namespace plt is equal to matplotlib-cpp is equivalent to the Python's using matplotlib.pyplot as plt thing. So if you have used matplotlib in Python, you know exactly what I'm talking about. Next we start writing our main function. We'll say int main, then we start our first example, and then we first create a vector of doubles and name of the vector is suppose y, and it has 4 values 1, 3, 2 and 4 suppose, and then we create another vector which is x. So basically we have a set of data points x versus y, that's what we are looking for. So suppose x value is 1.5, 2.5, 3.5 and 4.5. okay, so once you have this x and y, we'll start plotting. So we'll say plt scope resolution operator, then we invoke figure method, then we type plt plot, then the name of the variables. The first one is the variable along the x-axis of the plot, the second variable is along the variable that we want to plot along the y-axis. Then we define the line type, in our case which will be a blue line, and this is the marker type O dash. And then we also be labeling this plot so that if we use legend, then we'll have the name of this particular plot. So we'll say label, and its value would be suppose its trend, data trend. Okay. The next thing is we need to set x label. It's similar to what we have done in Python. So it's suppose the time in seconds, and then we also have y label, which is suppose observation. Maybe the unit is meter, doesn't matter right now. And then we'll assign the title of this plot. Title of this plot is suppose matplotlib minimal example, and then we'll invoke the legend. Okay. Once we have that, all we need is already there, and then we definitely have to call the show method, otherwise we'll not be able to see the plot. And we are good in typing the code. Next we'll see how to compile this code, because compiling any C++ code using matplotlib-cpp requires a little bit of work. That is our next goal, and we'll see it how it's done. Okay, now let's compile the code. So in order to compile the code, we invoke first G++, then we say we want to compile the code using C++11 standard, that is std is equal to C++11. Then we also want the warning option up, we also want the optimizer, and then we provide the name of the executable, which is in our case suppose prac underscore matplotlib prac underscore matplotlib, and then we also provide the name of the file that we want to compile, in this case which is matplotlib.cpp. Now we have the interesting part. So we now need to include a couple of Python functionalities. So we need to show the path to the compiler where the compiler can find the required files. So one thing I forgot to mention before is that matplotlib-cpp.h requires python.h files. If you open the matplotlib.h, you will see that it calls python.h, or it includes python.h in the file. So we need to tell the compiler where that python.h H file is available. So it's in my case, that is in home slash username anaconda3 envs, which is the environment folder, then the name of the environment, and then I say include slash Python 3.7m. Okay, then at the same time we also need the path to show the compiler where the compiler can find the numpy package, because matplotlib-cpp also requires numpy in Python to be used. So it will be using numpy under the hood. So we need to show where this compiler for this code will be able to find this numpy package. So again, copy this because the path is almost very similar, but instead of envs robotics, after that we need to remove the rest of the stuff. Then I type robotics lib slash Python 3.7 slash site packages, because that's where all the Python packages will be installed for the robotics virtual environment, and then I type core and include. So this will include the packages slash numpy slash okay. So I have the two required included files included. Next I have to define the library path where can Python find the Python libraries when it looks for linking different Python object files. So I invoke -l option to define the library paths, and then I again type the similar things, robotics, then I type lib, and then I say which file to link with. So it's -l Python 3.7m and also -l. So -l Python 3.7m is the abbreviation for lib Python 3.7m.o and .a files. And then I also have this -l Python pthread. So these are the two link options that I have to mention. I think we are good for compiling our code. Let's hit enter and see whether the code is compiled or not. As you can see, that code compiled without any error, and we have our executable ready. Let's see whether we have the executable. Yes, we see that the executable is there. Its name is prac_matplotlib, as we have defined here. Now we'll run the executable /prac_matplotlib, and we see the beautiful plot here using matplotlib-cpp. So here we complete one example how to use matplotlib-cpp and how to set up different paths that's required as we start writing the code. And at the same time, we also have seen how to set up the compilation process to compile any code using matplotlib-cpp. Especially, we are using here a different Python version. That's not the default one. We are using Python version in Anaconda environment, so the compilation and the environment setup procedure is little bit involved. However, I think this example was useful, and until next time, thank you for watching.